What's up, everyone? Today's video, we're covering section 4.6, which is over Cramer's Rule, okay? And Cramer's Rule is a way that you can solve systems of equations using matrices, okay? In this video, we're going to cover how to use Cramer's Rule for solving a 2x2 system, and then I'll do a second video for a 3x3 system, okay? So what Cramer's rule does, it uses the determinants of matrices in order to solve a system of equations, okay? Um, so we just came off of last section learning how to find a determinant of both a 2x2 and a 3x3 matrix. Now we are using or applying our determinants to solving a system with this new rule, okay? So here's how you would use Cramer's rule to solve a 2x2 system, okay? Two equations and two variables. You want both equations to be in standard form, meaning you need x and y on the same side of the equation and the constant on the other side, okay? So let's say we have the following setup, and we can find the solution for x to this system using the following format, okay? X is going to equal a determinant over a determinant. Now, the denominator of the determinant would have the following elements. It would have A, B, C, and D. And notice those four elements are simply the coefficients on the variables within the two equations of the system, okay? Now in the numerator, since we are solving for the variable x, notice the coefficients on x are a and c. Since we're solving for x, we're going to replace those coefficients with e and f to make up the first column, okay? But the second column is going to be the coefficient of y, b, and d, okay? So then you would simply evaluate each one of those 2x2 determinants. I would give you a value in the numerator, a value in the denominator, and then you just simplify that for your overall solution for x, okay? Now, if you want to solve for y using Cramer's rule, you'd have a very similar format. It would be a 2x2 determinant over a 2x2 determinant. The denominator would be the exact same determinant as the denominator for x, okay? So using the coefficients from the variables of your system, okay? And then in the numerator, since we're solving for y, we are now going to take the coefficients from the y variable, which are b and d, and those are going to be replaced with the constants of the equations. So e and f would make up the second column here. And then the first column would be the coefficients of x, so a and c. Okay, so think of these are like formulas that you can use to solve a system, okay? So let's now apply it to an example. Notice this system is set up perfectly for Cramer's rule because both equations are already in their standard form, okay? So let's say I want to solve for x. Here would be your initial setup. In the denominator, I'd have 5 and 4 in my first row, 3 and -2 in my second row, okay? And in the numerator, again, since I'm solving for x, the coefficients from x in my two equations, those will be replaced with the constants of the equation. So that would be 28 and 8 making up my first row, or my first column. And then my second column would be the coefficients of y, okay? And now I simply need to find the value of each one of these determinants. So I'm going to find that product, which is -56, and subtract it by that product, which is 32. I'll simplify that here in a moment. And down below, this product of -10 subtracted by this product of 12. And that's going to result in -88 over -22, which equals 4. Okay, so the solution to this system is going to have an x coordinate of 4. All right. Now, there's a couple different ways you can find the y value for the solution. Okay, you could simply take 4 and plug it in for x into either one of the original equations and then solve for y, much like we would do when we are solving a system by, substitution or elimination. Or you could set up Cramer's rule again, but this time for y, and that's the approach I'm going to take. Okay. Now here's the nice thing. When I set up for y, I already know that the denominator, its determinant, is going to simplify to -22 because I know it's the same determinant from the denominator of x using Cramer's rule. Okay. In the numerator, my first column would have the coefficients of x, which are 5 and 3. And then since I'm solving for y this time, the coefficients from the y variables get replaced with 28 and 8. Okay. All right, so I evaluate the top there. This product is 40 subtracted by this product, which is 84, all over that -22. So that's -44 over -22, which simplifies to 2. All right, you put these now together and we can say the solution to this system is the point of 4, 2. Okay. All right, so now it's your turn to practice. Pause the video, go to practice 1, try it yourself, and then check back with me.